Today, let us solve numericals on number of cooling tubes and arrangement of cooling tubes of a transformer. Before solving, take down these important formulas. The first one is height of transformer tank, that is HT, is equal to height of transformer, that is core, plus clearance along the height, that is delta H. WT, width of transformer tank, and BT, breadth of transformer tank. Second formula, surface area of tank can be calculated as ST is equal to 2 into HT into the bracket BT plus WT. Third formula, the total loss or heat dissipated by tank without cooling tubes, W is equal to 12.5 ST theta R. Fourth, total heat dissipated or lost by tank with cooling tube at 35% convection, W is equal to 12.5 ST theta plus 8.8 AT theta. If the heat dissipation is 40%, then it should be W is equal to 12.5 ST theta plus 9.1 AT theta. Area of one cooling tube can be calculated as AT1 is equal to pi dt into LT. If dt value is not given, you can take it by default as 0.05 meter or 5 centimeter, and LT is the height of cooling tube, can be taken as LT is equal to 90% of height of transformer tank. And finally, the total number of cooling tubes can be calculated as N is equal to AT by 81. Note down the numerical. A 250 kVA, 3-phase core type transformer has total losses of 4800 watts. The transformer height is 125 centimeter and 100 centimeter by 50 centimeter in plan. Design the scheme of tubes for 35 degrees Celsius. The diameter of each tube is 5 centimeter and they are spaced 7.5 centimeter apart. The average height of cooling tube is 105 centimeter. The provision of tubes improved convection by 35%. Write down the given things. The total loss W is given as 4800 watts and height of transformer is given as 125 centimeter. Write it as 1.25 meter, and he has given in plan 100 by 50 centimeter. Remember, plan means when we are seeing a transformer from the top. So when we see the transformer from the top, we can see width and breadth, not the height. So therefore, WTR is equal to 100 centimeter and BTR is equal to 50 centimeter. Then allowable temperature given as theta is equal to 35 degrees Celsius. Then diameter of cooling tube is 5 centimeter, which will be 0.05 meter. Then length of cooling tube or height of cooling tube is 105 centimeter or 1.05 meter. The spacing between two alternate coolings is 7.5 centimeter. The approach to solve all the numericals of this type should be the same. First, try to find out the tank dimension. Therefore, height of tank HT is equal to HTR plus delta H. HTR is given and delta H is a standard value, that is its range is delta H is equal to 30 to 60 centimeter. I have told you already, if any value is specified in a range, then take its average value, and the average of 60 to 30 is 45 centimeter. So the total height of the transformer is 1.7 meter. Similarly, calculate width of the transformer tank. WT is equal to WTR plus delta W, where delta W ranges from 10 to 20 centimeter and take the average as 15 centimeter. So therefore total width of transformer tank is WT is equal to 1.15 meter. Similarly, find out the breadth of transformer tank, that is BTR, sorry, it's actually BT. BT is equal to BTR plus delta B. Again, delta B value ranges from 10 to 20 centimeter. So take the average as 15 centimeter. Therefore, total breadth of transformer tank is 0.65 meter. After calculating the tank dimensions, next step should be the temperature rise theta R. Remember, you have to write total losses by plain tank without any cooling tubes is W is equal to 12.5 St theta R. In this equation, already we know the total losses as 4800, and we don't know the value of St, we don't know the value of theta R. So first let us find out the value of surface area of tank St. St is equal to 2HT into the bracket WT plus BT. Substitute the value and solve. You will get St as 6.12 meter square. Now using the above equation, you can write theta R is equal to total losses divided by 12.5 into St. Therefore theta R is equal to 4800 divided by 12.5 into 6.12. Therefore theta R is 63 degree Celsius. Theta R is nothing but the temperature rise of a transformer without any cooling tube. But we have to restrict the temperature rise of transformer to 35 degrees Celsius only. Therefore, now let us calculate the surface area of one cooling tube, that is 81 is equal to pi dt into LT. Substitute the value, you will get 81 value as 0.165 meter square. We know that the total number of cooling tubes can be calculated as N is equal to 80 by 81. Substitute the values and you will get the answer as 41.8. So always write a round figure, that is 42 cooling tubes. After calculating total number of cooling tubes, next step is the scheme and arrangement of cooling tubes. The spacing between two cooling tubes is given as 7.5 centimeter. Therefore, the first approach should be try to understand how many cooling tubes are laid down along width. So to do that, write down this number of cooling tubes along the width can be calculated as 115 centimeter divided by 7.5 centimeter. 115 centimeter is the width of transformer tank. So substitute the value, you will get answer as 15.3. So 15 cooling tubes are going to be placed or arranged along the width. Similarly, number of cooling tubes along breadth 65 divided by 7.5. 65 is the breadth of your transformer tank. So therefore you got the answer as 8.66. So the nearest number is 9. So take it as 9 cooling tubes. Now let us see how to arrange these cooling tubes along your transformer tank. So first, to do that, draw a rectangle box which is nothing but a plan of transformer. So you can see, so when you are seeing the transformer from the top, as I said you can see only length and breadth of your transformer tank. So along the length we have placed 15 cooling tubes. So let's start from one number. I'm placing 15 cooling tubes, and this arrow mark will indicate the arrangement or the alignment of cooling tubes from 1 to 15. Then next, along breadth I'm going to place 9 cooling tubes. So that's why I have written starting from 16 and ending at 24, because 16 to 24 is 9 cooling tubes, that is 16, 17, 18, 19, 20, 21, 22, 23 and 24. Next, again along length you have to place 15 cooling tubes. The next number after 24 is 25. So I have written 25 and add 15, you're going to get 39. So the number of cooling tubes again placed along the length are 15, and next after 39 the next number is 40. So along breadth again I am going to arrange 9 cooling tubes, but we know that the maximum number of cooling tubes we need to place is 42. So I am writing here 40, 41 and 42 because we don't have more cooling tubes to arrange along the breadth. So this is how your approach should be there for all the numericals associated with number of cooling tubes, schematic and arrangement. Thank you.